Based on our description so far, we've noted that lists can do everything tuples can do, and more. They can be declared and sliced and nested and unpacked the same ways, with the added bonus of being mutable. That means we can add new items, remove items, sort items, change items, and more. So you might wonder, why would you ever use tuples? And that's actually a really interesting question, and if you ask a bunch of different people, you'll get a bunch of different answers. Generally though, there are a couple conventions we follow to decide whether to use lists or tuples. First, we often use tuples when we're definitely dealing with a predetermined number of items. We use lists when the ability to add or remove from the list would actually be useful and relevant. Consider our quotient and remainder function from before. Whenever we use this function, we know we're going to have exactly two results in our output. We'll always have a quotient, and we'll always have a remainder. There will never really be a need to have additional values in that tuple. Each value has a distinct meaning. They represent qualitatively different things, so we use a tuple in that case. That connects nicely to the second convention. When we think of a list of things, we typically think of things that are somewhat homogeneous. In other words, the individual things on the list are somewhat similar to each other in some way. So think about a real-world list. A grocery list is a list of items you want to buy at the store. A to-do list is a list of tasks that you want to complete. There's something fundamentally similar in every single item on that list. With a to-do list, each thing is an item to do. With a grocery list, each thing is an item to buy. It wouldn't make sense to put call Becky on a grocery list. And although we could probably figure out what we mean by it, it wouldn't make a lot of sense to put yogurt on a to-do list. We could probably guess that we mean go buy yogurt, but just on its own, it doesn't have the same kind of meaning as the other items in that list. So we usually use lists when the individual things on the list are qualitatively similar. We use tuples if they're qualitatively different. Now that convention can be made even stronger. When I say convention, I mean that this is something that people generally do, although we don't have to do it. Another common convention is that lists are used for like data types. Now Python technically lets you create a list that has multiple data types in it, but by convention, we usually only use lists if every single item in the list is going to have the same data type. That's kind of similar to what's going on here. We can imagine this data type being items at the grocery store, and a list for our grocery list is going to contain only things that are of that type. This is largely because lists are often iterated upon with loops. We go through a list one by one and execute the same body of code for each item in the list. And we can generally only do that if we can do the same kind of thing to each item in the list. So here, what we would do for each item in our grocery list, well, we would buy each item. If we had an item that said call Becky on our grocery list, it doesn't make sense to say buy call Becky. That just doesn't make sense. So for that reason, with lists, we usually operate only on the same data type, because that lets us run some code on every item in the list and know that it's going to work. Tuples are more often used to represent information that's unpacked into unique variables like quotients and remainders. Those have qualitatively different meanings, and so you're not going to just run some code on every item in a tuple. For that same reason, it's more normal for tuples to have different data types within them, because we're not generally expecting to be able to iterate over a tuple in the same way. But these are all just conventions. That means that while other programmers with whom you share your code will often expect these conventions to be followed, Python isn't going to stop you from doing things one way or the other. It's good to get in the habit of following these conventions though, partially so you can collaborate more easily with others, and partially because other languages aren't quite as flexible. Many languages, for example, require that every item in a list be of the same type.